So, picture this. Lamba gets home from school one day, and he's just feeling awful. He tells his big sister, Fiban, "I think I have a fever." Now she touches his forehead, and yeah, it feels warm. But is it actually a fever? To know for sure, she reaches for a thermometer. That simple little moment, it actually gets to the heart of a huge scientific question. How do we really know how hot or cold something is? Well, let's dive in and find out.
So here's our game plan. First, we're going to put our own hands to the test and see if we can even trust them. Then, we'll get into what temperature really is. After that, we'll look at two very different kinds of thermometers, learn the right way to use them, and finally, we'll see how temperature is literally all around us, all the time.
All right, first up, can you actually trust your own hands to tell you the temperature? Let's dig into why our senses might not be the reliable tool we think they are.
I mean, really think about it for a sec. Can you always tell if something is hot or cold just with a touch? You might think, yeah, of course, but a super simple experiment is about to show us something kind of shocking about our own senses.
Okay, check out this classic experiment. You've got 3 bowls, one with warm water, one with ice-cold water, and one right in the middle with plain old tap water. So you stick one hand in the warm and the other in the cold for about a minute. Then you plunge both hands into that middle bowl of tap water. And this is where it gets weird. The hand that was in the warm water, it feels the tap water as cold. But the hand from the ice water, it feels that exact same tap water as warm. It's because our nerves get used to the first temperature, which proves our sense of touch is totally relative.
And that little experiment proves a massive point. We just can't always rely on our sense of touch. Our idea of what's hot and what's cold can be easily fooled. So that means we need a much better, more objective way to figure it out.
So if our hands aren't trustworthy, what is? Well, this brings us to the whole concept of temperature. It's our reliable, scientific way to measure hot and cold.
To put it simply, temperature is just that, a reliable way to measure the hotness or coldness of an object. It's not about how something feels to you or me. It's a consistent scale that lets us measure things accurately every single time.
And the tool, the hero of this story, that lets us do this reliable measuring? It's the thermometer, of course. This is the device that takes all the guesswork out of it and gives us a nice, precise number.
But hold on, it's not quite that simple. You can't just grab any old thermometer. You need the right tool for the right job, which brings us to our little tale of 2 thermometers.
The 2 main types you're going to see are the clinical thermometer, that's the one made specifically for measuring human body temperature, and the laboratory thermometer, which is what you'd use for science experiments and, well, pretty much everything else.
Let's look at the clinical thermometer first. This guy is a specialist. It's designed for one job and one job only, taking our temperature. And that's because a healthy person's temperature stays in a really tight range, usually between 35 and 42 degrees Celsius. So this thermometer is built to be incredibly accurate, but only within that specific little window.
And the magic number you're usually looking for is 37 degrees Celsius. Now keep in mind, this is just an average. You might be a little higher or a little lower and be perfectly healthy. It even changes a bit during the day, but 37 is the number we use as our general benchmark for what's normal. Okay, now let's meet its cousin, the laboratory thermometer. This tool is the complete opposite. It's built to handle the huge range of temperatures you might find in a science lab.
Yeah, its typical range goes from -10 degrees all the way up to 110 degrees Celsius. Perfect for measuring ice or even boiling water. And that's exactly why you'd never use it to check for a fever. It's just not precise enough for the tiny changes in body temperature. And you'd definitely never use a clinical one for boiling water. It would literally break.
Okay, so we have the right tool for the job. But having the tool is only half the battle. Now we need to learn how to use it the right way. Because your technique is everything if you want an accurate reading.
When you're using a digital clinical thermometer, there are a few golden rules. Number 1, please read the instructions first. For hygiene, you've got to wash the tip with soap and water or an antiseptic before and after you use it, but be super careful to keep the screen dry. And here's a pro tip. Don't hold it by the metal tip because the heat from your own fingers can actually mess up the reading.
Now for the lab thermometer, it's all about placement. Just look at the proper technique here. The thermometer is held perfectly straight up and down, and the bulb at the bottom is completely surrounded by the liquid. But, and this is important, it's not touching the bottom or the sides of the beaker.
So let's recap those rules for the lab thermometer, because they're super important. Hold it vertically, no tilting. Make sure the bulb is swimming in the substance, not touching the glass.
This next one is crucial. You have to read the temperature while the thermometer is still in the liquid. The second you pull it out, the reading will start to change. And finally, get your eyes right down to the same level as the measurement to read it accurately.
Okay, let's zoom out a little bit. We've been focused on specific measurements, but temperature is everywhere. It's a huge part of our world, from the air in your room to the weather report you see on the news.
You've probably seen a thermometer just like this one on a wall somewhere. It's measuring the air temperature, which is the exact same kind of information that meteorologists use for the weather forecast. It helps them predict the highs and lows for the day.
All this talk about accuracy brings us to a really powerful quote from an amazing Indian physicist and meteorologist named Anna Mani. People sometimes called her the weather woman of India, and she famously said, "Wrong measurements are worse than no measurements at all." That just perfectly sums up why it's so important to use the right tool and the right technique.
So let's boil all this down. What are the key takeaways? First, our sense of touch is tricky and can't be trusted. Second, temperature is the solid, reliable, scientific way to measure how hot or cold something is. Third, thermometers are the special tools we need to do that job. And finally, you have to use the right thermometer for the job and use it the right way. We talked a lot about measuring heat, and we know things can get unbelievably hot. I mean, the sun's core is a mind-blowing 15 million degrees Celsius. But that leaves us with one last really cool question to think about. If that's how hot things can get, what's the absolute coldest possible temperature in the entire universe?